My name is Gunavena Shiva and my roll number is 4H5. Today my topic is designing and implementation of an embedded edge processing water quality monitoring system for underground waters. Abstract. Maintaining the water quality of a pond is one of the main issue on aquaculture management. Water quality represents the condition of pond based on several water parameters such as dissolved oxygen, temporary pH, and salinity. All of these parameters need to be strictly supervised since it is affect the life sustainability of a cultivated organism. However, do is said to be the main parameter since it is affect the growth and several rate of the stream. Therefore, a water quality controlling and monitoring system is needed to maintain water parameter at acceptable value. The system is developed on a mini PC and microcontroller which are integrated with several sensors and actuator forming an embedded system. Then the system is used to collect water quality data that is consisting of several water parameters and the control the DO as the main parameter. In accordance with the stability need against the sensitivity environment, a fuzzy logic based control is developed to maintain the DO rate in water. This system is equipped with a SIM 800 module to notice the farmer by SMS, built-in Wi-Fi module for a web-based data logging, and improved with Android-based graphical user interface to perform the user-friendly monitoring from the experiment result. A fuzzy controller that is attached to the system can control the DO at the acceptable value of 6 pm. The controller is said to have high robustness since its deviation for a long time use is only 0.12 ppm. Another test shows that the controller is able to overcome the given disturbance and easily adapt when the DO set point is changed. Finally, the system is able to collect and store the data into cloud storage periodically and shows the data on a website. Introduction. Indoor strip cultivation is currently a popular farming technique which is used by a lot of stream farmers in Indonesia. To the base concept of this farming method is cultivating the aquatic organism is a small environment to control the water parameter essentially easily. The environment condition of the shrimp pond can be assessed by its water quality data which is described by several water parameters such as DO, pH, salinity and temperature. DO defines the amount of dissolved oxygen in a pond. pH represents the scale of water acidity from 0 to 14. Salinity expresses the saltness or amount of the salt dissolved in body of water. Based on the minimum limit of DO for shrimp cultivation is 3 ppm or 3 mgl. It means the pH level for shrimp cultivation process must be in the range of 7 to 8.5. The salinity of water in the pond must be in the range of 0 to 35 ppt or 0 to 35 grams per liter. It means that the amount of salt in 1 liter must be in the range of 0 to 35 grams. Meanwhile, the allowed temperature for the cultivation process 26 to 35 degrees. All of these parameters need to be strictly maintained to support life sustainability of the stream. Therefore, a water quality control and monitoring system is needed to overcome supervision and maintenance problem. The monitoring function in WQCM system is developed to measure DO, pH, salinity and temperature of water in the pond continuously. The system is made from a mini PC and microcontroller forming an embedded system with a several operator, sensor and modules attached in it. Besides measuring the water parameter, unexpectedly water condition to perform the function The system is equipped with SIM 800 module to notice the farmer by SMS if any bad condition occurred. In accordance with the need for automatic data logging, the system is also connected to the internet to send the water quality to data to website periodically. This mechanism is far effective than using human intervention to do aquaculture management tasks. However, another problem is appeared due to the lack of cultivation area. Related work. There is a plenty of controlling and monitoring system that has been developed in several kinds of research. In an optimal PID control is used to manage dew concentration in the wastewater treatment plant. An expertise system is also developed to control the dew rate in a wastewater aerobic treatment process. A physiologic control can be used to control the dew concentration in a activated sludge process and SBR water treatment process. Another approach like heuristic methods such as neural adaptive control is applied to control the dew of activated sludge bioreactor. Then a nonlinear control is implemented to control the dew rate of a pseudobacteria fermentation. Several work about monitoring system also have been developed 13, 14, 15, 16, 17 to do continuously monitoring take with easy in another land. IoT based system is performed to give effective monitoring and data recording in 18, 19, 20, 21. All of these systems have been proven to work properly in their replacing human intervention on monitoring, supervising and accurate the data. System design. As mentioned in the previous section, there are several particular systems that have their own specific function in the cultivation process. The grand design of indoor cultivation with its particular system can be seen in figure 1. There are several things to be concerned with developing the system. As the first step, a calibration for each sensor that is used to measure water quality parameter is performed. Then the topology and work mechanism of the system that shows how the water parameter is measured and stored into cloud storage is well described. A clear discrimination about fuzzy control development for dew rate management is also given. Picture about the shrimp pond. System architecture. Describe the overall architecture of the embedded system, discussing the selection of sensor and data execution method, explaining the choice of an edge processing approach. Sensor integration. Detail the types of sensor used in monitoring water quality parameter, temperature, dissolved oxygen content. Explain how these sensors are contained to the embedded system. Data processing and analysis. Discuss how data is processed and analyzed at the edge. Explain an algorithm or technique used for a real-time data address, how outliers or animals are detected. Communication and data transmission. Describe how the system transmits data to central monitoring station of database. Discuss the choice of communication protocol and the reason for their selection. Power management, user interface. Conclusion. WQCM system is implemented in an indoor shrimp pond and proved to be able to supervise the water quality and maintaining the dew rate based on several experiment results. The dissolved oxygen can be managed around the set point value of 6 ppm in 78 seconds. The system is able to adapt when a disturbance and the set point changes are given. The system is also able to be used for a long time. Used with their average dissolved oxygen value of 6.05 ppm and small deviation value of 0.12 ppm. Another subsystem such as a early warning and monitoring system for a shrimp pond has been introduced. This system can measure water parameters such as a dew, pH, salinity and temperature continuously and upload the data to cloud storage periodically. By using this feature, the farmer does not need keep an eye to the pond and record the data manually. warning system also worked by sending an SMS to remind the farmer when a bad condition occurred. Last, the Android based graphical interface has been proved to the support the farmer in understanding the water quality and data. Thank you.